slides visible, please? My voice clear?
Yeah, it is
Yes,
clear.
sir.
Okay, thank you very much. Today we will speak about the automation control of hybrid power system, uh, microgrid. So microgrid can be connected with the grid or it can be isolated. And then the latest what we want to reach is the smart grid, smart power systems. So first of all, let us speak about the hybrid power systems, microgrid, uh, how we'll design the hybrid power systems, and then we talk about the smart grid. Okay, so some uh, introductory remarks, why we need the hybrid power systems, where we need the hybrid power systems. If we see the situation in several underdeveloping and developing countries, still, like, in the 21st century, uh, several countries, significant part of the community still do not have like the electrical connection to the central utility network. And the reason for that could be several reasons, like the locations, community are really in remote areas, hilly areas, so very difficult to reach. If you plan to construct the uh, power supply through the grid connected system, long transmission line, the remote community can be staying, in very small population, just few houses. The population could be, very small in those locations. So it doesn't make justify with the cost that for the people of like 500, we are making the transmission line for 500 kilometer. It becomes extremely costly. Okay. So due to the several reasons in terms of remoteness, cost, and non-availability of sufficient funds for the government to invest in these remote areas. So it is difficult. If you consider like countries like the African continent, so their huge population still do not have access to the grid supply. Okay, thanks to our country that our country, like most of the villages, have now been electrified, but still we need to go big way. It is not just like uh, meeting the minimum requirement that all the villages just like simply electrified because the electricity being supplied might be just minimum. People may have just, basic electricity like one or two lighting bulbs, and that too also for few hours. Okay, so that if you call in terms of power supply, like it is BPL, below poverty line, that it is not the sufficient electricity or the good quality of electricity that what we would be expecting. So in those remote areas, uh, how the electricity is being limited electricity is being supplied, and what that so basically it has been used through basically the diesel generator. Okay, and the power supply in those area, in those locations, can be called with the different names. You can see there are several names, what we call as the remote system, decentralized, standalone, autonomous, isolated hybrid power system. So you can find in the literature large number of names uh, for supplying of power to these locations. The most common way of supplying electricity to those locations is through diesel power plants. Okay, the diesel generator is advantageous in the way that it is extremely proven technology. We have been generating electricity through diesel generators over hundreds of years. Okay, so it is well proven technology, very much reliable, if it can be maintained properly. But there are several disadvantages with the diesel generator. That cost of electricity is huge. That could be cost of fuel, then cost of operation and maintenance. Diesel generator require huge maintenance, and then of course the transportation cost. I worked a few years in the Fiji Island. Fiji Island is a small island country having the population around 1 million. Uh, so there are several small islands, but there are 2 or 3 islands. So grid supply is just only available in 2 main islands, and on the other small islands there is no grid supply. Even in the main islands, significant part of that their supply is coming from the diesel generator. And at that time, the installed, because it's a small country, installed capacity was around just like 200 megawatt. Out of that, 50-60 megawatt is coming from diesel generator. So 25, 30, 35% is coming from the diesel generator. So diesel generator power supply is extremely costly. Cost of fuel, transportation cost. You see in island country like how the diesel will be supplied, and cost of the transportation, the fluctuation of diesel prices in the international market, operation and maintenance cost. Like if some of the parts are out of order, so the operation maintenance is really challenging task. Okay, so there are several, and of course pollution, noise, so many problems with the diesel generator. Uh, so, uh, and on the top of that, there is one book I will tell you which very nicely talks about the design of wind diesel hybrid power system. So this paragraph I took from the book. I will mention the reference. It is NEC Fair wind diesel hybrid power system. So when we are designing a the wind diesel hybrid power, like the diesel system for those isolated system. Now we have to keep consideration for the future demand, and we have to design the diesel system considering the 2 times of the peak capacity. Okay. So just to ensure that the diesel supply is sufficient. So it means that the diesel system can be 5 times the rating of the average load. So the diesel generator, you will see that will be quite oversized. So it means that electricity being produced from such a large size diesel system will produce the extremely costly electricity. Okay, so there are several issues with the design of diesel system. Now, in the remote communities, poor people, they cannot afford to have this costly electricity. So this is like really a challenge for them. So the cost of electricity can be made comparable with the grid supply if we can integrate the renewable energy sources which can be available in the remote communities, like wind, photovoltaic, can be small hydro, small or even mini or micro. Even these days we talk about the pico hydro as well, or other resources like biomass, biogas, whatever the renewables resources available in those locations. Maybe if these can be integrated with the diesel system, depending upon the availability of natural resources. So we make this hybrid system. The cost can be brought down, even the diesel system can be reduced, and we can supply the power to the community not only just like basic few hours, but we can supply them power for the longer duration, and they can use uh, some other devices, television, and they can improve the quality of life. Okay, so the wind diesel hybrid power system or hybrid power system will offer several advantages. That of course the size of the diesel engine will and battery storage etc. will be reduced, fuel cost will be reduced, so system will become very much economical. Okay, so in a hybrid power system, basically the natural resources, wind, PV, hydro, are the main constituent of the systems and designed to operate in parallel with the diesel, because the renewables basically they depend upon the weather conditions, uh, natural conditions. So basically to maintain the reliability of the supply, these are operated in parallel with the diesel generators. Okay, so in hybrid systems, basically to generate the electricity as far as possible from renewable sources will reduce the cost, that generally uh, they do not require the fuel. Wind, PV do not require fuel, even biomass, biogas, so uh, doesn't need the costly fuel. And diesel we operate just to ensure the continuity of the power supply. So what if you see, as we have already discussed, that natural resources like wind is highly fluctuating in nature, and it will affect the quality of power supply. So this is like very interesting fact that in past or still now we are generating electricity from the fossil fuel power plants, coal-based power plant. So these plants, like you can say, very dirty in terms of creating a lot of pollution. But if you see the quality of power supply they will produce, so this is really very good. Means that voltage, controlling the voltage and frequency, maintaining the voltage and frequency is very easy. So the quality of power supply is really very good. But if we talk about the renewables, okay, so they are very neat and clean, environment friendly. But if you see the quality of power produced, so this is not good. This is like poor quality, because the wind is highly fluctuating during night, no sunshine. So basically, renewables offer large number of challenges. So it means the control system required for them is is really very challenging task. So maintaining the voltage, frequency, power supply, power quality with renewables, it is really challenging task. They are weather dependent, so prediction forecasting becomes another major issue. Okay, so here in the hybrid power system, the parameters to be maintained are basically similar what we have in the conventional power systems, maintaining of the voltage, frequency, which will obviously determine the stability and quality of the power supply. Okay. So the control of voltage and frequency in the hybrid power system is you can say the basic requirements. So the how the frequency deviation will take place. So frequency deviation, as I explained in the previous lectures as well, that frequency deviation is related with the real power mismatch between the generation and demand. Okay, so if there is imbalance between the real power generation and consumption, so that will lead to have the consequence of the frequency deviation. Whereas voltage mismatch is the indicator of that there is reactive power imbalance between the generation and demand. So we have to ensure that in hybrid power system, how we maintain the balance between the generation and demand to control the frequency, to control the voltage. Okay, so this frequency control is usually called as the automatic generation controlled AGC, or also called as load frequency control LFC. And then the how we control the reactive power. So I'll show a simple schematic diagram for the hybrid power system. So you have the uh, diesel generator. So diesel generator will generally use a synchronous generator because these are generally constant speed uh, generators. Then we have the natural resources. It, it can be wind. Wind can be connected on uh, induction generator or synchronous generator. Then there can be other types of natural resources. Here I have just shown like two for the simplicity, but there can be any type of natural resources, photovoltaic, biomass, biogas, mini, micro hydro, etc. Okay. Then you need to have the appropriate control system. Okay. The key things what we have to manage in the hybrid power system is, of course, uh, maintaining of the frequency, standard 50 hertz frequency. So that frequency is mainly related with the balance, real-time balance between the real power generation and demand. So real power generated because of the burning of the fuel or through the natural resources. So whatever the electricity is being generated, real power. So in real time, it has to be balanced with the consumer loads. Okay. Of course, some part of the electricity we can store in terms of like storage systems, batteries, etc. Uh, so we add the batteries to introduce the uh, stability and reliability of the system. But like for example, if there is sufficient wind, even we do not require the diesel generator at that time, even the storage system is fully charged. So what we do with the excessive power generation from wind? Okay, so we have to maintain the balance. If the balance is not there, then uh, frequency deviation will be there, and it can lead to that system uh, becomes unstable, or it may not work well. So whatever the excess power is there from the wind system, we have to dissipate that in terms of what we call as the dump load. Okay, dump load could be resistive load or inductive load, where the excessive power will be just dissipated. If we can find some useful means of that excess power, like it can be used for space heating or some other application, so that will be really great. Then also we have to, of course, ensure the balance for the reactive power generation and demand. If there is mismatch, then it will cause the voltage deviation. So the reactive power support can be through capacitor banks or some more advanced support in terms of like static var compensator, etc. So we need the suitable reactive power support as well. Okay, so this technology is already there. We have a large number of hybrid power system already working in the different parts of the world. There is no issue about the technology. Technology is quite mature, and we have several hybrid power system. So about the technology control, there is no much issue. But the generally, like there was experience that we come through like in Fiji Island, that like basically these are in remote locations. So how this will be operated and maintained? Of course, these will be operated and maintained mainly by the local community. Okay, so the local community has to be well trained and proper procedure has to be developed that how this plant will be operated and maintained. Okay, even the technology is there, still these plants can be unfunctional after installation of few years because the community have no experience and they cannot operate. Even how the billing will be there for the hybrid power system when the community is consuming electricity, how they will pay back, whether they are willing to pay back, what is the meaning of revenue collection. So all these different aspects needs to be carefully considered. So the failure of this hybrid system may not because of the technical reasons, but it can fail because of the several reasons, like there is no proper experience training to the remote community how they will operate and maintain their power plants. Okay. Now this is very nicely the design of wind diesel hybrid power system very nicely explained in the book Neck Fair, design of wind diesel hybrid power system. So we just consider some of the aspect about if you are designing a wind diesel hybrid power system, what aspects you consider. So diesel generator operation will be which way? The operation of diesel generator can be two types. One can be you have the diesel generator running continuously, 24 hours. Okay, so in that case your control system will be very simple, right? It will not be economical. It will consume a lot of fuel. But if you want to design a economical system, then we have to keep the diesel generator operation intermittent. Like whenever there is requirement, we only operate diesel generator during that time, and remaining time we try to keep the diesel generator switched off. We have to also ensure that we do not operate diesel generator too frequently. Like, we started 10 minutes diesel generator, next 10 minutes we switch off. So too much frequently switching on and off, it will cause excessive wear and tear on the generator. The generator life can be reduced. So we should ensure that the on and off operation of the diesel generator should be the optimal one. And at the same time, we want to ensure the good fuel saving from the diesel generator through the intermittent operation. Okay, so the different power supply aspects that we want to maintain in the hybrid power system or conventional power system as well are in terms of we want to maintain the voltage stability, want to maintain the frequency stability, we want to maintain the power supply in terms of harmonics, phase balance, electromagnetic interference. We want to maintain within the limits. Three-phase supply, we want to distribute uniformly, so that system performance is better. Now, let us speak about the choice of the diesel generator in the hybrid power system. We have basically three types of generator: DC generator, synchronous generator, and induction generator. So this DC generator is not used because wherever we need the DC supply, we can convert AC supply into DC by means of rectifier, which becomes you know, more convenient, easy, less costly, requires less maintenance other than using the DC generator for generation of electricity. And of course, DC generator we know requires the lot of maintenance. Then other option is synchronous generator. Synchronous generator are basically used for constant speed application. They run at constant speed. We can control uh, the reactive power. The synchronous generator will require the synchronization. They can only run at the synchronous speed. So the synchronous generators are generally more costly than induction generator for the small size generators. Like we talk about the small size generators like being used in the hybrid power systems or as the standby small size generators are more costly than induction generators. Okay, so with the diesel generator, we will be using the synchronous generator. Then induction generator. Induction generators are very popular in in wind and small hydro applications. The I explained when we talked about the wind system, the different uh, types of generator technology: type 1, type 2, type 3, type 4. So in hybrid power systems, it is not like a wind farm. It is hybrid power system. We can have the wind turbines can be one, two, three, not too many. So the size of the wind system will be small. It will not be like 1 megawatt or 2 megawatt wind turbine. It will be small for this small community. So its size can be small, 50 kilowatt, 100 kilowatt, small size. So for that, the generator technology we will be using mainly is type 1 or type 2. Type 1 uses the squirrel cage induction generator. So this is very robust. The squirrel cage induction motor is very rough and tough, very robust. Okay, so we can use the type 1, or we can use the variable speed, that is type 2, in which we can add the resistance in the rotor circuit. So this generator technology will be used in the hybrid power system. Now, like the role of power electronics in renewables or hybrid power system is extremely important. We need the power electronic converters for the conversion of AC power into DC or DC power into AC. So we need the power electronic converters. Like we know that PV will generate the DC supply that we need to convert to the AC for feeding to the grid or to supply the most of the load. Even from the battery, so in the hybrid power system, we need the power electronic converters. So this role of power electronic is extremely important in the renewable energy systems. Now, if for example we are designing a hybrid power system, if you have to design the system, what should be the wind turbine sizing? How will decide the wind turbine sizing? Okay, so just to explain in the very simple way that the wind turbine size should be greater than the maximum consumer loads. What are the maximum consumer loads you have, plus small system losses. Okay, except like where you are planning to have the large storage system. Okay, so basically, of course, in the hybrid power system, there can be diesel generator as well. But when we are designing, will just try to plan that the use of diesel is minimum. So diesel is just we are keeping as a backup or to use minimum. So the system sizing for the wind turbine will decide that it should be like the larger than the consumer loads. Okay, but in practice, we have to also keep in mind that what are the commercially available wind turbines uh, locally or overseas. So if we got, say, for example, the wind turbine requirement is 15 kilowatt, for example. If there is no availability of 15 kilowatt, so we may see what is the next size available, 20 kilowatt or two 10 kilowatt wind system. So what are the commercially available wind turbine size? We have to give consideration to that as well. And then of course we have to keep in mind about the cost consideration as well. This is very important. So we have to give the cost consideration in mind as well. Now we have to design, we have to have the dump load as well in the hybrid power system. So purpose of dump load is to dissipate the excess energy from the wind which cannot be stored. Battery is already full. So the purpose of dump load is to dissipate the excess energy through the wind system. It is obvious that we will not generate the electricity from diesel generator and dump into the dump load. Okay, so it will be not a good decision that we are generating electricity from the diesel generator and dumping it. Okay, doesn't make any sense. So dumping of electricity is required only when we have the excess power generation from the wind. Even we are fully supplying the consumers, even the batteries are fully stored, but what we do with the excess power generation from the wind, and there is at that time there is no diesel operation, so the excess power we have to dump in the dump loads. So this must be, so how we decide the rating for the dump loads. So the dump loads should be able to accommodate maximum input surplus power from their system, which will require the knowledge that what will be the maximum power we might be generating from the wind system. And at that we can basically, when we are designing the system, we consider the adverse condition. Like we are designing the dump system, so we are considering that how much maximum rated power wind system is supplying, and considering that what can be the minimum load from the consumers, because we are designing under the worst condition. So what is the maximum wind turbine power supplied, what is the minimum consumer load, and diesel may be operating or diesel may be not running. So in those worst conditions, we try to find what should be the size of the dump load. And of course, like the consideration should be given that can we make use of some dump load in some useful means like the space heating, etc., rather than simply wasting the excess electricity. So if we can make use of some useful means like the space heating or some other applications in the remote areas. Okay, so when we talk about the design or suitability of the storage systems in the hybrid power system, so storage is very important to maintain the reliability of the power supply. So we can have the options in terms of like batteries. Then there can be other storage technology you may find in the literature, like Flywheel, superconducting magnetic energy storage system. So we have to keep in mind that what is the role of batteries? What is the basic purpose of the batteries? and what are the options available, what could be the optimum choice for the storage options. Okay. Now let us talk about the load and demand management in the hybrid power system. Okay, so problem of this wind power variability can be managed by the load demand management. So here the basic objective is to match the uh, uh, match the load with respect of generation. Okay, so whatever generation is there, we try to match load accordingly. So load, that is called as the load management, managing the power from the load side. Okay, so in that case, like whatever the generation is there, if there is less generation, then of course we use the less load. So basically, uh, some of the loads we may need to switch off. So there would be mechanism of the priority switching and priority loading, that in which way the load will be supplied. So in the remote community, the priority should be given if there is hospital, so that should be given preference. If there is you know school, also we just give the priority uh, in the loading. So there should be appropriate way of the load demand management. And the 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 switching on and off the load. Okay, so the consumer should be aware of this pattern. If they are well aware in the advance, so they are prepared. So it is very important that the the switching or loading, it should be done in the systematic and planned manner. So we have already talked about these hybrid power systems. This is, I think, additional uh, regarding the frequency and reactive power control. So this is like one of the very important aspect, how we do the reactive power and frequency control. I did the research, my PhD on this reactive power control. Even the frequency control is very important. Professor Bhatt is also very expert. So we published this book with the Narosa publisher. This was also published with the Alpha Science UK. So it very nicely gives you the analysis for the reactive power control and frequency control for the hybrid power systems. Okay, now we have covered uh, like basically power generation from the fossil fuels, power generation from renewable distributed generation. We covered the power generation from wind in terms of onshore, offshore. We talked about the photovoltaic systems. We talked about slight bit about the storage systems in terms of batteries. There can be several other technologies like the in terms of solar, concentrating solar power, wave energy, fuel cell, geothermal, uh, biomass, biogas, etc. So there are a large number of other technology available, but the other technologies like CSP, wave, tidal, etc. So they have not been so uh, much commercially successful. They might be in experimental stage or in the small scale implementation. So if we see that what sort of the challenge we have, what are the opportunities with the renewable power generation. Okay, so this slide very nicely explains about that. So my apology that you may if not able to see clearly. So this is taken from the paper Electric Power Systems, published in 2015. Here we have already talked about the present status, like in 2019 or 2020, the installed capacity from the wind is around 650 gigawatt. So you can see in 5 years, so the capacity is almost double. Okay, average size of wind turbine is around 2 megawatt. Okay, of course we may have the largest size of wind turbine which is around 8 gigawatt, but this large size will generally will be installed in the offshore wind. Okay, the popular technology is DFIG, or the PMSG is also being used. Then the cost, the average cost of energy is 6 cents to 12 cents per kilowatt hour. What are the research challenges and opportunities? The research challenge and opportunities are in terms of there are reliability issues, interconnection issues, grid code development and compliance, developing of the medium voltage converters, developing of the new semiconductor devices. So these are research challenges and opportunities. The trend we speak until 2050, next 20 years. So the power generation from wind can increase 5 to 10 times in the next 20 years. The wind turbine size can go up. We already have seen that we reached the wind turbine size 15 megawatt. We may see in future 20 megawatt wind turbine as well. The cost of electricity from the wind is quite getting saturated, because the technology is quite saturated. A lot of installation take place. So there may not be significant drop in the cost of the wind system. If we compare with respect of offshore, the installed capacity currently we have around 30 gigawatt, mainly in the Europe. The average size of wind turbine you can see in the offshore is obviously larger. In onshore around 2, offshore average size is 3.6. Mostly the large size wind turbine will be installed in the offshore wind. Then the cost of electricity, presently it is, you can see onshore like 6 to 12 cents US. Here offshore 14 to 25. So you can see larger than the double. Okay, so this is more costly. The issues are more or less similar. Some additional issues are in terms of like the developing or construction of the offshore foundation for the wind turbine. There are issues around the power quality issues. High maintenance is one of the issue. Then the trend, like in the next 10 years, the capacity might be expected to go around 150 gigawatt. There is a good prediction that cost will be significantly reduced, because this offshore technologies is still in the initial stage. So as more and more installations are there, the cost will come down. The photovoltaic, the current capacity around 650 gigawatt, or we already reached 700 gigawatt. The cost of electricity is 8 cents to 36 cents. So basically it can be slightly costly than wind, but cost will come down as we have more and more installation, because still the technology is new, and as more installations are there, so cost will come down. There are a lot of opportunities and challenges in the PV system, designing of the PV systems with with uh, with high efficiency materials, like in terms of thin film. Storage is very important. Uh, Integration issues we have to see, and then, you know, the life of the PV systems, uh, including the life of the inverters, even for the small size PV system, designing of the micro inverters. So these are the uh, some challenges and opportunities. So this slide gives you very nice some sort of comparison about the development in the renewables. Now, uh, let us briefly talk about the smart grid. Uh, Smart grid, like, whatever we have this power system, we want to make it very smart. Uh, so, so whatever the issues we have seen can be reduced or minimized as far as possible. So, but the smart grid is not the complete replacement of the existing one. Okay. So, for example, we have the existing coal-based power plant. It doesn't mean in the smart grid we close down all the smart grid, all the coal-based power plant immediately. Then situation will become more complicated. Okay. So we have to uh, need both centralized and distributed generation. Of course, we need to integrate, add more and more renewable energy into the grid so that our generation mix is significantly in the favor of renewable energy. Electric vehicles are likely to come in the future. Delhi government already made its announcement. So electric vehicles are likely to come. We have to see, we have to develop the infrastructure for the charging of electric vehicles, what impact it will have on the grid. So we have to give consideration for that. Storage system is very important in managing of the grid. Then for the grid, like a country ours, we have this length around 3,000 kilometer long transmission network. How the health of the transmission network will be monitored in real time. So we need the phasor measurement units. Smart metering is required. Smart metering is required in the distribution system to collect the revenue, uh, operate the distribution system in optimum manner. Consumer can use their electricity, uh, optimize their energy bills, so the consumers can get benefited. Then we need to make use of information and technology to optimize the capital assets in terms of all this, like infrastructure, transformers, cables, etc., reduce the operation and maintenance cost. So if you compare smart grid with respect of traditional, so in the smart grid, we need both centralized and distributed renewable generation. Electric vehicles are likely to come. With the renewables integration, power flow becomes bidirectional, and the, the, there is two-way communication in the smart grid. So consumers have their saying that how they are going to use the electricity. They can optimize their energy bills through digital smart meters, and the smart grid should have property of the self monitoring and self filling. And then whether we have the conventional grid or smart grid, we would like to see which way the consumer is benefiting. Here in the smart grid, consumer will have the several choice. There is no more monopoly. Like for example, uh, in the mobile technology, if the consumer is happy with the one supplier, they can switch over to the another one. Like there are options: Vodacom, Geo, etc. So same way, like if the consumer is unhappy with the one utility, they can switch over to the another one. I worked in the Australia, these things already existing there. Like, if you want to switch over from one utility to another, you can switch over the mobile phone. Okay, so basically, the consumers have the choice. There is no more monopoly. It will introduce healthy competition. Cost will bring down. Consumer gets the better quality of supply, get the reduced cost of the supply. So these are the some of the features what we expect from the smart grid. Now, if we see what are the subsystems of the smart grid. So first one is like the infrastructure. Infrastructure in terms of we have the power generation, transmission, distribution, conventional power system. But in the recent time, we have of course power generation from the renewables. Electric vehicles are likely to come. So there will be infrastructure for this renewable plants integration, generation, separate transmission lines required to develop the infrastructure. Electric vehicles are likely to come. So the infrastructure needs to be developed for the electric vehicle charging. Even the electric vehicles can supply power back into the grid. So the new infrastructure needs to be developed. Then smart information system in terms of smart meters, sensors, phasor measurement units. There will be smart grid. So smart grid has the three components. We have the power grid. In addition to that, information and communication technology. Information through smart meters, sensors, phasor measurement units. Then communication, it can be wireless or wired system, wired or wireless system, fiber optic communication system. So there is significant emphasis on the information and communication system, which can make the system smarter. Then how we are going to manage the smart grid? So what are the some of the aspects that we expect? That how we manage the demand, have the energy efficiency. We try to have the demand profile shaping, minimize the transmission and distribution losses through integration of more and more renewables, even reduce the emissions from the conventional power plants. Then how we are going to manage, what are the methods and tools, different software optimization techniques, machine learning, game theory, etc. So these come under the management of the smart grid. Then the third aspect is protection. Protection is extremely important aspect for the smart grid. As we have seen with the integration of renewables, power flow becomes bidirectional. So existing protection scheme may not work well, which will require significant modification improvement in the protection scheme. So protection becomes extremely important aspect of the smart grid. So the protection is very essential to have the system reliability and minimize the failure. So the protection will help in making the grid with the property of self-healing. Even we have this microgrid can be connected with the grid or it can be isolated. So how we can protect that? And the most important thing, that through smart meters, utility will have lot of information from the consumers. Okay, so maintaining the security and privacy of those information is extremely important, because through those information, uh, the utility can know the consumer behavior. Like they can see the pattern of the energy consumption. They can know the information in terms of that what time people are going office, what time they are coming back. So the security and privacy of that information is very important. So it has to be ensured that there is mechanism and the security and privacy of the information is maintained. So this is extremely important. Now we are just almost end of the session. So to give you some of my research areas, some key publications, books recently published. So the power system protection, as I mentioned, is very important in the renewable systems. So how we can protect smart grid environment. This book published last year with the CRC Press. So in this can be a nice book maybe for the undergraduate or master level. Then edited some book on the handbook of the renewable distributed generation, handbook of the renewable energy technology. And this year we published the book dealing with the power electronics, drives, some advanced applications, electric vehicles, etc. uh, Written by authors from IITs and uh, Delhi College of Engineering, what we call it DTU. So it deals with the power electronic applications, advanced applications, drives. Uh, so that's all. Some of the key reference what we have used, like for the dealing with the conventional power system, I use this book, Electrical Machines, Drives by Wildy. Then I explain about the how we can improve the efficiency of coal-based and thermal power plants. Then this I already explained the handbook of DG, handbook of renewable energy technology, and most important thing is that if, like, for example, you want to start a new course on the renewable energy. It can be based on overall renewable energy, based on the wind, photovoltaic system, and some other technology. So you might be looking for some good book in which, like, there can be large number of solved and unsolved problems, and it is really very nice, easy for the student to understand. So I really like this book, Renewable and Efficient Electric Power Systems by GM Masters. Okay. Wiley Press, first it was published in 2004 and then published in 2013. So this is really very nice written book, can be adopted as the textbook. Then the reference which I was mentioning, if someone wants to get more information about how to design the wind diesel systems, so although quite old, but still explains very nicely the concept of the wind diesel system design implementation. So very nicely talking. Then some of the research papers, then review papers on the large scale PV integration, the stability aspects, then uh, the book chapter, then a review paper on the distributed generation published in IEEE. So these are some of the reference which I have used. Some of the my research student who have contributed to my research. So we are ending of the session. So just to have the concluding remarks, uh, the the course dedicated towards the automation and control in the industry. So we basically picked up the industry, electric industry. Even all the other industries will depend upon this electric industry. So this is extremely important industry. Industry or industries of industries, so on which the economy of any nation will develop. So it requires huge investment in the generation, transmission, and distribution. We have been generating electricity through coal-based fossil fuel. The issues are uh, emissions. We have the other resources for power generation in terms of large hydro, nuclear, and then uh, of course the the control for voltage, control for frequency, the technology is quite mature, but the whatever development it is taking place, it is around the control. The control technology is really changing very fast. Automation and control. If we see the control system now or the control system in a plant 20 years earlier, so we can see there is huge difference. Now the control is similar way control. What we are using in our mobile, it is basically touch screen. We don't see no more the buttons. We have just like the kind of just touch screen. We can just control boiler pressure, temperature, even the synchronization of the grid. It can be completely automated. Okay, so then the because of the emissions, we are moving from the conventional to the renewables. We want to add more and more power from the renewables, wind, photovoltaic systems. We have nicely explained about that. Diesel generator is required in the buildings as the standby. Diesel generator is required in the renewables uh, isolated system. So we have covered the diesel generator, and then we have talked about the hybrid power systems, smart grid. So smart grid is like something ideal situation what we want to look, that we can supply the power supply, generate, supply, distribute power in a very smarter way with the minimum emissions, and the consumers can be feel satisfied. They can minimize the cost. They can manage their power system. So uh, we we have made a lot of progress, a lot of development in the electric industry, but still our job is not done. We have long way to go, because still there are community who do not have the sufficient electricity. Just they may be able to manage with the basic electricity like one bulb, two bulb. So they are still the conditions of power supply is not great. So there is long way to go ahead. Engineer have to work a lot. So without taking too much time, respecting for the time, I'll just like to stop here. I hope you enjoyed my presentation. I believe it had been fruitful. So I'm happy to take questions, and uh, participants can contact me at uh, later stage through email, and they can see the research publication from my students through this my Google Scholar. So without taking much time, I would like to just conclude my session, and I look forward to have some questions from my presentation, maybe from all what I present. So thank you very much. I look forward to have some questions.
One question from Dr. Ramesh Chaurasia. Sir, what is the need of a smart grid if all the things are running perfectly in the world?
Yeah, so it is Ramesh ji, it is very good and very interesting question, that we we think that things are running running perfectly, running good. Okay, so even you compare in simple way that uh, like we are human beings, so always we expect better and better. Okay, something is like the basic needs. Something like when we say we are fine, something then we say okay whether we are like kind of luxury situation. Even the air conditioning is not considered like the as a luxury. Okay, so load demand is growing in the developing countries. uh, the people still still, do not have the sufficient electricity to improve the quality of life. uh, so even renewables basic infrastructure needs to be developed. And tell, how much amount we talk about these smart meters, how much people have really implemented. NCRA situation might be okay, but if you go in the remote, there is no electricity. How you talk about these smart meters? So basically, still, like countries in the developing and underdeveloping countries, there is long way to go. I worked in Australia. Basically, it is developed country, for example. So there we can see that, the development which has taken quite uniformly. Uniformly means that, uh, the all the people have electricity, good supply, whether you go in the cities or you go in the remote, there is not much difference. But here, if we see like in our Indian system or some other developing countries, so cities might be might be good. Okay, like I worked in South Africa. Like if you see Johannesburg city, of course, lot of crimes and other things. But if you see the infrastructure, so it is really great. Even I went for the conference in USA. Even if you see the roads infrastructure, it is not less. But when you go in the remote areas, African continent, so you'll see the situation really very poor. Okay, so basically in the developing and underdeveloping countries, we may think, we are sitting in the metro cities, we may think that everything looking great, perfect, but still, if you go in the remote area, people don't have electricity to improve their so basically there is huge way, and the technology is changing very fast. Like we are generating electricity from the coal, we are getting electricity, so we may not bother whether sometime we have thought that, in our home electricity is coming. Have you thought that whether this electricity is coming from coal or from the wind? Even we have, can we identify? I share you very good, very interesting experience. I worked in, in Australia. So basically, even, they're promoting, because power generation from the renewables is more costly. Like, can we afford slight bit more cost to support the renewables? So there, a system try to develop, try to promote, they're saying that, okay, like if you are willing to say pay $1 extra per week, so we will ensure to supply 25% of your electricity through renewables. So basically promoting for the renewables, because you suggest you donate maybe $1 extra a week. So you just promote the renewables, because renewables is more costly. So there is long way to go or think in terms of smart grid. Like in the term of smart grid, we can have few demonstration project just partially, but there is long way to go to reach the smart grid.
I agree, sir. But another question in my mind, okay, if we are going to be develop latest technology, just like a smart grid,
Yes.
then definitely the maintenance charges will be increased, because as far as the electronics things are developing, the whole system is to be repaired by the complete PCB replacement. So at that way, the maintenance will be increased definitely once it is to be going breakdown. That is the issue.
Yeah, Bhardwaj, this is really very good and very interesting point you have raised. In fact, sometimes, like, people may think that, smart grid is is kind of like the technology, or it is like some unique box sort of thing. People may think that, smart grid is like, some different type of laptop or computer, or this technology will just buy or do things. But if you see, it is like massive. Anything which we are doing for the for the some key objective benefits. Like for example, we are generating electricity from coal-based. Whatever we are changing from coal to renewables, this is the best way of doing smart, right? So even we are thinking that the issues are around the theft and fraud of the electricity. So there is need for these smart meters. So it has to be on the massive level with some well-defined objective. Okay, of course, there it will cost, but it will come with the benefits. We may see that renewables more costly, lot of issue, wind is there, wind is not there, but we have to have some patience and we understand, and in long run it will be the need, and uh, we have to move forward with that.
Correct, correct, correct. So can we conclude the session now? Madam Anjali Rana,
Are there
Yes,
some
sir.
more questions?
I think no question. And it is written by Professor Abhilash. All of your sessions were wonderful and full of the knowledge.
Thank you for the nice comments, all the faculty members, participants. It has been great to present me. The basic objective here want to encourage, motivate young engineers, future engineers, faculty members to do good research, do the good things for our country to make progress. So that is our objective. And I really want to thank Professor Bhardwaj and his team for doing this course in wonderful way, both hybrid and grid connected and isolated in the sense online and offline. So I am delivering several programs, but they are now completely online. So it is really great to see that both online and offline. So this is really great. Maybe AICT, they may see that this worked well, so they may can see this model being implemented in some other programs.
Okay, sir. Thank you very much. Lot
Thank
of
you.
thanks. I will try to the best of my power to develop the nation.
You are really doing very good job, Professor Bhardwaj.
Thank you.
Thank you, sir.
Thank you.
Thank you so much for a very wonderful session. Really, such an informative session. It's our pleasure to have you as a speaker. In future, we hope some more session from your side. Thank you so much, sir.
Yeah, it will be my pleasure. Maybe, hopefully, when the situation improves, maybe in few months, maybe in July, maybe when I have vacations, so hopefully I look forward to make physical visit to your college.
Yes, yes, sir. Thank you, sir. Thank you so much.
Okay, sir. Thank you very much.
Thank you all participants, organizing team. All the best to everyone. I will disconnect, but all the best. Look forward to meet you again.
Thank you, sir.
Thank you very much.
So there is a 15 minutes break of tea time. So everybody is requested to be here at 11:30. We will have the expert from Denmark, Professor Sanjeevi Kumar, after that.